couldn't be traveling in the right direction and rotate the experiment 90 degrees and still have it work so that Earth was traveling with the medium, right? One of those had to be not in the direction Earth is moving through the ether. Does that make sense?
Yes.
Okay, so one of those is akin to Alexis driving towards me as he throws the egg, and the other is akin to him just driving parallel to me as he throws it. Does that work?
Mm-hmm.
So, and since they rotated the experiment 90 degrees, there's no way that he could have been driving towards me in both of those cases. Yeah?
Yeah.
That's the crux of this. So, in one of those, the measured speed of light should be less than the other. Yeah?
Mm-hmm.
Except that what they saw is a null result. They saw no difference. And so what did they do? They asked for more money. And they built a bigger experiment.
And
And-
they should be rejected, like, oh, okay, what I surprised wrong, we should be going that way.
And what did they see when they did this again?
Same
result.
Same result. A null result. They won the Nobel Prize for a null result. It's an important null result. No matter what they did, they could not see a difference in the speed of light. So what this told us is that not only can we not see, touch, taste, smell, or hear the ether, apparently light doesn't know it's there either, right? Have I told you about the ghost in my house? Very polite, doesn't make noise, doesn't move my stuff around. I can't see, touch, taste, smell, or hear said ghost. How is that different than not having a ghost?
Yeah, no.
It isn't, right? There is no ghost in my house. Don't tell me otherwise. I scare easily. I also don't believe in ghosts. So. The ether isn't.
It is.
Yeah. We thought light needed a medium to travel through, and so we invented one, right? That's the.
Around what time did that happen? The guys trying to.
This was the late 1800s.
1800. So Maxwell.
Maxwell gives us this idea of light as a wave with a speed c, and
Others
they
will
start
come this.
trying to explore
So
this.
right after those guys tried to prove that there was a medium and.
Well, once light was thought to be a wave, the consensus was, well, waves need media. And so Michelson and Morley set out about trying to see if they could find evidence of this light traveling through the medium.
So it was after that when someone said, well, we don't need a medium.
It's this Michelson-Morley experiment that gives you a pretty good idea that you don't need it. It still hung on for a while after that. So people still weren't entirely convinced. I'll tell you, there are probably still physicists who would tell you it's there, it's just not, it doesn't have observable consequences. I don't know how that's different than it not being there, but, but again, I'm a lowly experimentalist. That's my, that's my out in that. So we're okay enough with this. But again, I don't know that we should have been surprised if we really took this to heart, right? If we really believed that we're going to agree on the laws of physics in all inertial reference frames, then if Maxwell can derive the speed of light from fundamental physical constants, then the speed of light should probably be a fundamental physical constant, yeah?
Yeah.
At least in vacuum. So that's where we find ourselves. And now let's use a simple heuristic to. So Einstein, really interesting person, right?
No.
You've probably seen pictures of Einstein as like an older person, right? You know, the uncombed hair, the unshaven, didn't button his shirt, often no socks, had a closet full of the same outfit. He kind of lived into this idea of the eccentric scientist as he became more and more famous. But if you see pictures of him as a young man, you know, clean shaven, hair combed, tie, button shirt, you know, looked the part. He was an interesting guy.
That patent office, that's a good at him.
He applied. He replied to every piece of mail he ever got, even after he was famous. He actually hired assistants to help him read, sort, and respond to his mail. You might have, you know, there are posters on like bus stops that say stuff like Einstein was no Einstein at math. That's not true. Einstein taught himself calculus from a book at age 12. He was a good mathematician. But that comes from a letter exchange he had with a young girl, where, you know, he asked her, you know, what's your favorite? He responded to her letter, and he said, "What's your favorite subject?" And she said she liked all of them except for math. And he wrote back something to the effect of, you know, "I assure you, whatever your problems with math are, mine are still the greater." And it was because it was a joke. He was working on general relativity at the time, and it was a lot of math. Somehow that morphed into. It is true that he was, you know, late developing. I don't think he spoke until he was like 4 years old. You know, he was also a somewhat sickly child. But, you know, he was a good mathematician. He wasn't as good as his first wife, but he was a good mathematician.
His friend is a good
So his first wife was an amazing mathematician. She was a mathematician. He was a good mathematician for a physicist of his era, but he, you know. Anyways, quirky guy, but he also wasn't the greatest of students.
a wolf of student.
He had a tendency to only want to work on things that he wanted to work on. And so, you know, some of his professors, especially in grad school, thought he was a little bit lazy, a little bit arrogant. And so when he got out of grad school, he couldn't get work as a physicist. By the way, it also had something to do with the biases of the era and the area that he lived in. But it was also in part that that he didn't go out of his way to make friends with his professors, and so they didn't help him out much. He wound up working as a patent clerk in Bern, Switzerland, and he references this as some of the most productive time in his life because the job wasn't very hard for him, and he spent a lot of time just walking through the hillsides, thinking about physics. Specifically thinking about Maxwell, who he idolized. And so he started asking himself, you know, what would happen? He took this first postulate more seriously than most, I'd say. This idea that we're all going to agree on the laws of physics. And so he said, well, you know, Maxwell can derive the speed of light, then it seems to me like there's the speed of light. And so he started thinking, well, what would happen if I was running alongside a wave of light? What would the universe look like? And it was from that he started to get to special relativity, which is what we're going to spend the next couple weeks on. And you'll see that special relativity is a lot of algebra. Conceptually challenging. but it's just algebra. General relativity is hard. Hard conceptually, hard mathematically. It's a lot of tensor mechanics. So that we'll speak of in kind of rounded edge terms, but special relativity, there's no reason why you guys can't understand that in full. Right now, you probably could have done it a while ago with the math that you already know. So, 1905, Einstein publishes 3 papers while not working as a physicist, not employed as a physicist at least. Any of those 3 papers was worth the Nobel Prize in physics. And in physics, you win the Nobel Prize for a single contribution. Any of those 3 papers were worth the Nobel Prize in physics. Special relativity is probably the one that you're going to recognize as it's going to lead us. What's the most famous physics equation you know?
E equals mc squared.
It's going to lead us to E equals mc squared. That's going to pop up along the way. But he's going to describe Brownian motion. He's also going to describe the photoelectric effect. Any of those was worth the Nobel Prize. You probably would think that he'd get it for special relativity or general relativity. He doesn't. He gets it for the photoelectric effect. And actually, it was overdue by the time he did win it. There was a lot of anti-Semitism, even in the Nobel Committee, and they actually went without awarding the Nobel Prize one year because the committee couldn't decide whether or not to give Einstein a Nobel Prize. It was a brokered settlement, and they eventually did give him the next year the Nobel Prize for the prior year, but not for relativity, not for the thing that was probably, they're all amazing, but maybe relativity is just a touch more amazing. I don't know. Photoelectric effect is also amazing. I don't know. But they gave it to him for the photoelectric effect because it was very, very easily already experimentally demonstrated. So, and we'll talk about that, and we'll actually do that one in lab. I can't do a lot of special relativity experiments with you because, again, it requires incredibly great speeds. All right, so that's a long preamble to, we're going to try a lot of Gedanken type experiments. If any of you actually speak German, I apologize. My grandmother says I speak French like a valley girl. I really don't speak German. So Gedanken is my attempt at the German word for thought. I'm pretty sure that's not how you're supposed to say it. I don't know if you guys are aware of this, but I have 2 older brothers, and they're both jerks. If you ever see them, kick them in the shins. But when I was a young person, I came up with a plan, and I carried it out. When they had children, I offered to babysit, and I put every poison word I could, PG level, into their ears about my brothers. But my little nephew loves being pushed on the swing. Like, squeals. Probably less so now. He's 22. But and he doesn't like it when I call him my little nephew anymore. But still. So one thing my brothers did give me is I am actually reasonably quick. They gave me 2 things. I'm reasonably quick and I can fake cry. The winner in my household growing up was the first one to make it to a parent crying. So let's just try a simple heuristic. This isn't the sum total, but let's say that I was babysitting my niece and nephew. And it looked like it was about to start raining. In fact, maybe lightning.
That sounds fun.
I'll tell you that, I don't know if still, again, he's 22, she's 20, 19. Almost 20, wow, I'm old. But at least when they were little kids, I could outrun them. So,
Pretty sure you can get them in distance.
it was the short legs. And my niece was crawling apparently, but you know. Let's say that there are a pair of lightning bolts. We don't even have to be running for this to be true, although I'm going to make it back to the car before them. If I see lightning bolt A and lightning bolt B strike the ground at the same time, does my nephew?
No.
Why not?
Your nephew would see bolt
Then
A,
A.
B first, then A.
So-
The distance between A and B.
In order for the light from strike A to reach my nephew, it has to have already passed me, right? Does that make sense?
Yeah.
So that sort of works? Okay. This simple heuristic is kind of the first dent in classical physics. And I'm going to say that because if we don't agree on simultaneity, right, we don't agree on the order of these events. If I say that they occurred simultaneously, but my nephew doesn't. In baseball, my beloved baseball, thankfully, is actually going to have a season this year. They say that the tie goes to the runner. Einstein's going to tell you there's no such thing as a tie, right? So if we can't agree on simultaneity, then all of a sudden we're going to be in some trouble, right? When it comes to trying to describe things classically. It's thoughts like this that made Einstein realize he needed a more accurate way of tracking events. And so let me see if I can. So relativity of simultaneity, right? Events deemed simultaneous. It's actually even more broad than this, but I'm going to come back to some of this later. Relativity of simultaneity. I don't know if this is how you spell simultaneity. This isn't even different frames, but we could make this work in a different frame also. So this is just a consequence of there being a speed of light, right? That light doesn't travel instantaneously. So Einstein realizes that to make matters work, he needs a very accurate clock. More accurate than anything that was available to him in the early 1900s. His miracle year was 1905, right? What's the thing that Maxwell tells him he can trust? Remember, he idolizes Maxwell. What's the thing Maxwell tells Einstein he can trust?
Speed of light.
Speed of light. So Einstein decides to build a light clock.
This wasn't his head, correct?
What's that?
This was,
It's a Gedanken experiment. Is that the? It's in his head.
it's in his head, it's not.
I'll show you why it's in his head in a second. In its simplest incarnation, it is a flashlight, although I guess he probably didn't have a flashlight, but some kind of lantern and a pair of mirrors. Call me old-fashioned. I like a clock that ticks once every second. And so, speed of light (3 times 10 to the 8 meters per second, 186,000 miles per second. It's not miles per hour, it's miles per second. So we're going to call one tick of this clock to be a to and fro of the light. And so in order for this to tick once a second, it is going to be, Einstein makes it 93,000 miles tall. This is why it's in his head, right? So we have that, so not scale, there's Einstein. It's an anachronism. In 1905, he was still neatly groomed, right? Put wheels on this. If you made a clock that was 93,000 miles tall, you'd want to show it off too. So what was the fast mode of travel for Einstein?
Trains.
Yeah. Over distances at least. So Einstein's gonna take this thing on tour. It's gonna charge 10 cents to see it. I'm not paying 10 cents to see a clock. Do you know how many Milky Ways I could have bought in 1905 for a dime?
None.
It's a trick question. None. They hadn't invented the Milky Way yet. It was a sad time to be alive. We were just waiting for the inventor of the Milky Way. But as cheap as I am, I will, for 10 cents I probably could have paid someone to make Milky Way. I will go to the side of the train tracks and watch this thing go by. And so, according to Einstein, what is the time here? If I, just to make life easier, let's call that h. What's delta t according to Einstein?
2h divided by the 3 times 10 to the 8th.
Can I say 2h over c?
Okay.
And since he's using miles, why is Einstein using miles? Well, because I'm the one telling the story. Where I use 186,000 miles per second for Einstein's clock. The light in Einstein's clock, at least. Okay? Now, again, I might be too cheap to pay to see this thing, but I will watch it go by. And so Einstein says that the time to tick once is 2h over c. But the path that I see, we both have to agree on the events. So the path that I see is as follows. Yeah. We both agree that the light left the flashlight. We both agree that it struck the center of the mirror above it. We both agree that it returned to from whence it came. Yeah? Now, we could do this first just conceptually, right? And then I'm going to throw some math in this with our remaining few minutes. Do I agree that the time for one tick for the light to make a to and fro is the same as Einstein? 1 second?
Yeah.
Yes.
Well, do I agree that the distance that the light traveled was the same?
Yes.
No.
I do not. Einstein said that the to and fro distance was what?
2h.
2h. But you can see that there's a right triangle here, right? And this is h. And so this is the hypotenuse, that's a base. The hypotenuse has to have a greater length than the base, right? And so do I see it take more time or less time?
More?
More time. So if we both agree on the speed of light. So according to me, we could build up our triangle as follows.
You had a question.
So if something is moving with a velocity in one direction and velocity in another direction, we usually just we add up the vectors of those two.
We could, sure.
In this case, the light is moving up and it's also moving to the right. So
Is that what Einstein sees? Einstein sees it just goes straight up and down. I don't see that, you're right.
yeah, but why would you assume that from your perspective that it's taking more time to get there instead of just going faster?
Well, so if we're going to stick to our starting premise that we're all going to agree on the speed of light, then that's already thrown out, right?
No, it's not, because the speed of light is still the speed of light, but we're just something is moving it to make it go faster. So it's not the speed of light from your perspective anymore, it's the speed of light plus the speed, plus the velocity of the light plus the velocity.
But the postulate says we all see the same speed for the speed of light, right? That's if we're going to go with this, then we're saying that we all agree on the things that come from the laws of physics. Well, if the speed of light can be determined from the fundamental electric field constant and magnetic field constant, then we both have to agree on the speed of light. Now, again, it's a postulate, so I'm not telling you a priori that this is true, but let's work through and see what happens, and then let's compare it to what we do observe and see how well it checks. So, but that is a totally valid possibility, right? That we don't actually agree on the speed of light. But let's see what happens. So, one leg of this, and I'm going to run out of time. Shoot. I'm going to cheat, and I'm going to jump to this so that next time when we show up, we can start from this.
You can say report.
You can solve this for delta t mark, and it's this. But note that this is also what Einstein sees divided by 1 minus v squared over c squared. Right? Because Einstein said 2h over c was the time measured. I am going to pick this up next time. Stuff's about to get wackier. So, as always, you guys are awesome. Have wonderful days. Thank you for stopping by. Don't be strangers. Enjoy your days, but not so much, and we'll see you next time.